Good morning and welcome to Minerals, Rocks, and Fossil Talks. It's time for some more Monday musings. And today's question is, what caused the end of the Jurassic period? And because I can, here is one of my favorite Far Side comics. Because why not? But in all seriousness, it is a tough question to answer. What did end the Jurassic period? And the answer is we don't know. But scientists do have a few hypotheses that they're trying to test. One is a major marine regression. There's evidence in Europe of a major sea level drop that would have caused localized extinctions like we see in the European fauna. And here are some paleo maps. So on this side here, you can see what Europe looked like in the late Jurassic. So lots of little islands in the sea. This is Europe in the early Cretaceous. We had some major sea level drop between 150 and 125 million years ago. So it very well could have caused a lot of extinctions in this particular area, if not globally. Another hypothesis is volcanism. The Chthonian stage of the late Jurassic saw the creation of a large volcanic plateau in the North Pacific and new volcanic deposits where Gondwana was beginning to separate. Now, none of these explain the northern continent of Laurasia having major extinctions, so, it could have impacted the climate enough to drop sea level. But I don't know if it was that dramatic a change. A third hypothesis is asteroid impacts. There were 3 minor asteroid impacts during the late Jurassic, one in South Africa, one in Australia, and one in Norway. However, none of these were big enough to create any sort of global impact, so unless it was combined with the volcanism, seems unlikely. Another hypothesis is just sampling bias. So we're getting a very, very small window into what we can see at this point in the past. And it may just be something as simple as missing a big part of the picture. And we'd like to try and include sampling bias into our work as it is, because we know that for the most part we're only getting a small window into things. But there's a lot we just can't account for. Like in Western North America, we're missing a chunk of time between the late Jurassic, Morrison, and the early Cretaceous Cedar Mountain Formation. We're missing 25 million years worth of information. And the most we can say is it was a time of erosion, maybe. Well, not maybe. Obviously it's not there, so it went somewhere. Or it was a time of non-deposition. So there's just nothing to look at. We also see that in the Jurassic, across the world, we have so many Lagerstätten with this amazing preservation with tons and tons of diversity in it, and there is a distinct lack of that in the early Cretaceous. We just don't have anything that preserves as nicely. There also appears to be a decrease in dinosaur diversity, specifically in sauropods, megalosaurids, and stegosaurids, as well as a complete extinction of non-pterodactyloid pterosaurs. This could be because there was a real extinction going on, or because they moved to environments that don't preserve fossils, such as mountains. That a lot of these animals maybe are living someplace we're just never going to know about. And we may never know. It's a tough area to look at. Our final option is that maybe there wasn't a mass extinction at all, just faunal turnover. This is something we see in the Cedar Mountain Formation itself. We can see dinosaurs going from more Jurassic-like to more Cretaceous-like. And perhaps there was another one from Jurassic to Cretaceous, and we either just haven't found it yet, or because of sampling bias, maybe it's just never going to be found because it's been removed or there was no deposition. Again, we might not know. But some interesting thoughts to fill your brain with. So, hope that you can come to appreciate a little bit the struggles we have when trying to piece together the past from what limited data we have at any given point. I hope you guys have a good Monday and a good week, and I will fossilise you later.